Hello everyone, my name is Kyle, and today I'm going to show you how to upres hair in Houdini in a more efficient way than just brute forcing and increasing the geometry of hair. This is my website. You can download the HIP limited commercial version here. I'll link this in the description. But let's jump into Houdini and figure out how to do this. So in Houdini, this is what we're going to be building today. We have our initial incoming lines here. We're simulating them. We're using some of the guide process nodes to upres them. So we have a much thicker simulation here, but we're just relying on the simulated guide geometry here. As you can see, I have a switch here to kind of show that action. So let's get started. Let's drop down a geometry container to start. And we'll just use a sphere for this one. Space H centers everything in the viewport. Let's make this polygonal. Drop down a scatter to scatter some points on this. Let's make this slightly higher frequency. Turn off relax iterations. Scatter fewer points on there. Let's also throw down a mountain stop. And this is just to add a little bit of noise to the incoming geometry. Let's drop down a line. We'll do a copy to points. Let's also resample our incoming line. And say about 10 points. We also want point normals for this. For the points, you want to put this above the scatter because it needs to read the geometry here. Let's change this to points. And Houdini just really likes objects lying on their z-axis. So let's change the line to be pointing in the z-axis. So now we have our initial lines here against our mountained sphere. Next, we want to set up the Vellum simulation. So let's use Vellum configure hair. We also need a Vellum constraint to pin the hair. Let's do pin to target, or not pin to target. Yes, pin to target. Let's drop down a group expression, and we're going to create our pinned group here. Make sure it's on pin. And the group expression is kind of cool because it has a whole bunch of these presets. They're kind of getting chopped off on the screen there, but I like to pick first point of primitive, which drops down this little bit of X. And as you can see, it selects the first point of each single line. In our Vellum constraints, let's put this on points and pin. We could keep pin type permanent, same as position for the orientation. Let's drop down a Vellum solver here. Connect up all of these inputs. Inside the Vellum solver, let's put down a pop win. Turn up the amplitude a little bit. This is just so we have some movement in the simulation. And since I have this curve view attribute flowing in, let's turn that on. Actually, I'm not sure if the Vellum solver gets rid of curve view or not. It may. So let's turn this off. If we just let this play, you can see we have our basic Vellum hair simulation. And the naive approach to this, and to actually make this a little bit better, let's pipe in we can put a null under the normal here and call this just base geo. So our network kind of looks like this now. And this is the basic Vellum hair simulation, right? We have hair kind of drooping over this weird sphere. And the naive approach to upres this would be to take the scatter and just increase the amount of lines. Let's drop down a resample node at the bottom here just for visualization. This is something I commonly like to do where I'm actually not resampling it, but we're using the resample node to create this curve view attribute, which is not visualizing for some reason. Houdini is doing Houdini things. Try again. Curve view. Was it a bad resample? Usually not the case. Let's just try a labs reset viewport. Okay, now it's showing up. Thanks, Houdini. So curve view just kind of helps visualize what's going on here. But the naive way to approach Vellum hair simulations is you just increase the amount of geometry coming into the scatter, right? And obviously here we have Upres hair, and you can increase this more and more. But the problem is that the more you increase the scatter, obviously, the much slower the simulation gets. Putting this at like, say, 5,000, for example, is going to be extremely slow. You can see this is chugging around like 1 frame a second here. In guides, there is this draw FPS box that's kind of useful sometimes. And you can see we're moving at a solid 3 frames a second. So Houdini has some cool, guide process nodes to make these higher res Vellum hair simulations without the cost of very high resolution incoming geometry. So what we're going to do is we are going to need a few nodes here. We're going to need a hair generate. This is going to be the main node we use. We're also going to need a skin attribute lookup here. And this is going to grab 2 attributes, the skin prim and the skin prim UV. And we're going to also need a rest position node. We'll put this after this. So how we want to wire this in is we take our incoming guides from the Vellum solver, and we actually want to decrease the resolution of this significantly. Let's put this around 148 points. We're going to need our rest skin, which in our case here is our base geo null that we created. And we want to put in the guides to the second input here, and our base geo here into our first input. So you have this weird visualization going on. I think this is to help visualize what the hair is actually going to look like. I don't like this, so I'm just going to drop an attribute delete, plug this in, and we want to get rid of this in the detail attributes, this GL shade open curves attribute. It's kind of getting cut off screen, but it should be the only detail attribute you can delete. And once we delete that, now we're back to our normal line visualization. We could also grab this resample, put this below the attribute delete, so we get our curve view back. Now this is where, Houdini kind of does its Houdini magic. In the hair generate node, we have a whole bunch of options to increase the radius. So it's using these initial guides and kind of scattering points around those guides, copying points to those guides, and then that new hair geometry is inheriting the motion of the initial guides. So if we select this and increase our radius here, we could also get rid of this grow unguided hair. You can see kind of what it's doing, right? It's scattering hair around that initial guide geometry and upressing the hair simulation. This doesn't look too great right now because our incoming resolution of the initial guide sim is so low. So let's crank this up a little bit higher. Let's put this at maybe like 500 lines. Now we're starting to get somewhere. It still looks a little clumpy to me. So in here, you could change some of the influence radius. That kind of helps break it up. You can change the density. So let's increase this to like 5,000. And what I also want to do is increase the scatter a little bit more here. Lastly, let's use a guide process length, set length here. And this will just randomize the length of each of the splines here, so we get kind of more organic look. And if we play this back now, we have now a very, very dense hair simulation. But it's playing back reasonably fast. And actually, it's not playing back super fast. So we probably have way more points than necessary. Let's see. Let's put this down to like 600. Yes, that looks pretty good. So now we're getting about 7 frames. What if we decrease the density to like 1000 here? 2000? So this node is basically upressing these incoming lines here. And I think this is the much smarter way on how to uprez your Vellum hair simulations. Because if you're just going to brute force increasing the scatter count, the Vellum solver is going to have to figure that out every single frame. Whereas here, we're using some base incoming guide geometry, and then we're scattering around those points to create this guy. So that is the tutorial. If you would like to check out some of the hips and rendering I did, you can check out my website and some of the links I put in the description for this. Thank you all for watching. Like, subscribe, do all that sort of thing, and I'll see you guys in the next tutorial. Thanks.